Okay, so this is the Precalculus Chapter 7 review. Let's take a look and we'll work through some of these. We start off with some of our trig identities. And as I begin to work to solve these, simplifying these, I have the sine of theta over the tangent of theta. Remember, it's always a good idea to look to try to write everything in terms of sine and cosine. So that's what we'll do in this first case here. So this is equivalent to the sine, and I don't really need to concern myself with the fact that it's theta over x or beta. So we're going to go ahead and just leave it as sine over the tangent. The tangent is sine over cosine. So the first thing I see here is that I have a fraction in the denominator. So I'm going to go ahead and multiply by its reciprocal instead of dividing by this. So I'm going to multiply this by cosine over sine. And what you'll notice happens here is that the sine values cancel, and you're actually just left with cosine theta. And let's look at the next example here. I have sine squared x plus cosine squared x all over tangent squared x plus 1. Well, I know that this is my Pythagorean identity, a squared plus b squared ultimately, so this equals 1 in the numerator. And then the bottom, if you look at your cheat sheet or in your notes from section, I believe this is 7-2, tangent squared x plus 1 is actually secant squared. And then again, I know that secant squared, and secant is 1 over cosine squared. So I'm just going to flip this over and actually make it cosine squared x. Okay, let's look at our tangent of x times cosine of x equals 1/2. I need to find the value of sine. So I'm going to write this in terms of sines and cosines. So tangent x cosine x is actually the sine of x over cosine x times cosine x, and I'll just put that over 1. And when you go straight across, that's actually sine times cosine all over cosine. These will cancel, and so this ultimately is the sine of x. And so if this tangent x cosine x is sine of x, and that's equal to 1/2, I've already found the sine of x. And scroll down, we'll look at a couple more. Now, I can find these values using either my half angle or double angle formulas. Now, cosine of 15, I'm probably looking at trying to do that with half angles. I'm not sure how I do that with a double angle, because I don't know what 7.5 is to make the angle of 15. But what I do know is that I can rewrite this or think of it as the cosine of 30 degrees over 2. And I do know what the cosine of 30 degrees is. So I'll write out my formula here. The cosine of alpha equals, or alpha over 2 rather, equals plus minus, and this is the radical, 1 plus cosine alpha over 2. And since we're in the first quadrant here, the cosine of 15, I'm going to use the plus value, and this is the radical of 1 plus, and the cosine of a 30-degree angle, in this case, that's the reference angle I'm using, is radical 3 over 2. And look at your formula chart, your little cheat sheet for that value, and over 2. So the only thing I've actually plugged in here is that value here. Otherwise, I'm just substituting into a formula. First thing I'm going to do now is I'm actually going to multiply top and bottom by 2 over 2, which is just 1. That's going to give me the square root of, distribute this, 2 plus, and the 2's cancel here from the denominator with this 2, radical 3 over 4. And what that does for me is it allows me to take the square root of the top and the bottom, and this simplifies down to 2 plus radical 3 all over just 2, the square root of 4, which is 2. Now look at the next one here, which is the sine of 5 pi over 8. Again, 5 pi over 8 is not a reference angle that we're familiar with, but if I use a half angle, make this sine of 5 pi over 4, which I believe is 210 degrees, and I'll go ahead and divide that by 2, so there's my 5 pi over 4 over 2, which is 5 pi over 8. And my formula here for sine then, let me switch colors so we don't get confused. The sine of alpha over 2 equals plus or minus the radical, and 1 minus cosine alpha all over 2. Now we begin to just sub in our values. And when we look at this, we're looking, okay, so since this is in the 5 pi over 8, slightly more than half pi, but not quite to pi, so it's in the second quadrant, so our sine value is positive, so I'm going to use the positive output from this. So I'm dealing with the square root, and I misspoke, 5 pi over 4 is actually 225, so 45 is our reference angle, and that value is down in quadrant 3, so that's actually a negative, so it's 1 minus the negative value from our 45 degree reference angle, which is radical 2 over 2 all over 2. Again, we're going to multiply top and bottom by 2 over 2, 1, and take the radical, distribute that through, so that's 2 minus the minus is plus, cancels there, over 4, and then we're going to square root top and bottom, so this breaks down to radical 2 plus radical 2 all over 2. And then the tangent of 105. A couple different ways to do this. Could have chosen, say, our sum formula, which would be maybe 45 plus 60. I actually elected to do this as tangent of 210 degrees, which is one of our reference angles, over 2. And that, for the cosine here to use in my formula, is negative radical 3 over 2, since we're dealing with the tangent of 210 degrees. And we'll go ahead and sub that in. The tangent formula here for the half angle is tangent. Let me switch back to blue here. Tangent of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Now we'll go ahead and plug in some values here. And since we're looking actually at the tangent of 105 degrees, 105 degrees is going to be in the second quadrant. The tangent, that is a negative or positive over negative rather. So it's still going to be a negative on the output, so I'm going to hang that guy out there. And I have 1 minus, and I have the negative radical 3 over 2 all over 1 plus negative radical 3 over 2. Now first thing I'm going to do here again is multiply top and bottom by 2. Try and remove some of those fractions. I'll distribute that through. And that's 2, we'll say plus radical 3 minus minus plus over distribute 2, and this one's minus square root 3. And now in order to simplify further, we'll go ahead and multiply top and bottom by the conjugate pair. So that is 2 plus radical 3 over 2 plus radical 3. Again, anything over itself is just 1, so that doesn't change the value. And I have the negative guy hanging out here. I distribute that through. A couple different ways to think about this. Notice here I'm multiplying this by itself, so I could think of this as 2 plus square root of 3 squared, which you'll see is going to simplify some of my work here. And then I distribute these, so I get 4. I have 2 radical 3 and then 2 negative radical 3. Those cancel. That's my difference of squares. And then negative square root 3 times positive square root 3 is a minus 3. And then I'm left with square root of 2 plus radical 3 squared over 4 minus 3, which is 1. I'm going to square root the top, square root the bottom, and that's going to leave me with, and apologize, it looks like I just went off my screen here, but that's going to leave me with the solution here. And this would be 1 in the denominator. I have a negative out here. Square root of the square is going to be 2 plus square root 3. And we'll flip it over and go to the next page. First problem here, finding the exact value given cosine theta equals 4 over 7, with theta having a terminal side in quadrant 4, find the exact value of cosine 2 theta. So we're in quadrant 4. My cosine then of 2 theta, that formula is 2 cosine squared theta minus 1. So I already know what cosine theta is. It's 4 over 7. So I'm just going to go ahead and dump that right into the formula. So there we are, 2 cosine theta, which is 4 over 7. I'm going to square that and then subtract 1. This becomes 2 square this first. 4 squared is 16 over 49. Double this here, so I get 32 over 49. Take away the 1. And then find the common denominator here, so 49 over 49. And this all equals be a negative 17 over 49. So we just used our double angle formula here for cosine right off of your note sheet. I already knew what cosine theta was, so I subbed it in, squared, and then proceeded to work. Okay, we've got just 2 left here, so we'll take a look at this one. This one is our angle sum formula, tangent of alpha plus beta. If the cosine of alpha equals 5/13, sine beta equals 3/5, and our angle here and here is between 0 and 90 in both cases, so that puts us into the first quadrant. So I'll draw a couple of quick little reference triangles here. Sorry, straighten these up a little bit. And for this one then, we'll call this the cosine theta here. Cosine is going to be, let's see, I've got 5 and 13, so that's 5 from our angle here, 5 and then 13 for the hypotenuse. This is actually a Pythagorean triple, 5, 8, 13. And then our second for beta, the sine is 3/5. So the sine of beta, 3/5, that's opposite over hypotenuse. This is actually another triple, 3, 4, and 5. So it makes it nice when I have these easy numbers instead of the radicals. And then we'll go ahead and look at our sum formula for tangent. And I see that the tangent of the sum of 2 angle formula is the tangent of alpha plus the tangent of beta over 1 minus tangent alpha times the tangent of beta. So it's the 2 added together and then over 1 minus the 2 multiplied. So now we'll just go ahead and begin to substitute values. So I know that the tangent of alpha, tangent is the opposite over hypotenuse. Again, this is our sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Toa, tangent, opposite adjacent. So that's the opposite over the adjacent. So that's 8/5. And to that I'm going to add the tangent of beta, opposite adjacent, which is 3/4. And that's going to be over 1 minus. And then I'm just multiplying these, which is 8/5 times 3/4. Now we'll just begin some simplifying. So I get 8/5 plus 3/4. I can go ahead and combine these if I want. Find the common denominator, that's going to be 20. So I'm going to convert this times 4, this times 4, so this is 32/20, plus I multiply 4 by 5 to get 20, so 3 by 5 plus 15/20 over 1 minus 8 times 3 is 24 over 5 times 4, which is 20. That would actually reduce down. It looks like 4 goes into both. That would be 6/5. And then we'll go ahead and simplify further. We'll combine these two, 32 and 15. 30, that's 40. 2 and 5 is 47/20. Doesn't look like that reduces a whole great deal. And then I'm taking 1 minus this, and this is just slightly larger than 1. It's 24/20. So if I make this 20/20 and go ahead and subtract, that's going to leave me with a -4/20 or a -1/5. Instead of dividing by 5, I'm going to go ahead and multiply by the reciprocal, which is -5/1. That's going to produce -235/20. And it looks like 5 definitely goes in all those. I'll pull up the calculator here. We'll make it easy. I have -235 divided by 20. There's my fraction. We'll hit math, enter, and it's -47/4. And our last one. And given the cosecant of alpha equals 4, and alpha having terminal side in quadrant 1, find the exact value of the cosine of alpha over 2. So, cosine of alpha over 2 has the formula plus or minus the radical 1 plus the cosine of alpha over 2. So first thing we need to do is figure out these ratios. A little reference triangle here. I know that cosecant is 4. I can rewrite this cosecant equals 4 as a ratio. That's 4/1. The cosecant is 1 over the sine value, 1 over sine. So if I flip that, I get sine, which means sine equals 1/4. So it's just the reciprocal of the cosecant value. So if this is my reference angle, we'll call it alpha. And I know that the sine, the opposite over the hypotenuse is 1/4. There's my ratio, a little Pythagorean theorem, 1 squared plus our unknown squared equals 4 squared. Subtract. And then we'll take the 4 squared 16. And it works out to the square root of 15. And now we'll go ahead and plug that in, radical 15. And I'm needing for my formula the cosine value. So the cosine of this alpha is equal to the adjacent over the hypotenuse over 4. So there's my cosine. So I'm going to use this guy for my formula. So I'm just going to go ahead and write it in. I know that this is in quadrant 1, so I'm working with the positive value here. So it's the positive of the radical. 1 plus the cosine, which is radical 15 over 4, all of that over 2. And just for a little simplification, just so I can remove it from the bottom, I'm going to go ahead and continue to multiply top and bottom by 2. I'll distribute that through, and I get the radical of 2. This is actually going to be 2/4, so that's going to reduce it to plus a radical 15 over 2, so half of that. All of that over, now I can bring this out. 2 times 2 is 4, and then the square root of 4 is 2. And we'll go ahead and just leave it there as a simplified version. If If you have any questions, come ready on Monday to ask any final questions, and we'll go over it, and then we'll go ahead and take the test. Good luck, and have a great weekend.